उस ऑर्डर में रखे, बस ऊपर नहीं वो मत करना, ऐसे ही ऑर्डर में रखना उसको। अबे भाई ये स्क्रीन ये नहीं आ रही यार, क्या बकचोदी हो गई इसको। ये हुई ना। ये देख भाई, तो स्ट्रीम चालू हो गई भाई। क्या करते हैं पहले। ओके, दिस इज 3 से 2 है तो वो 2 नेक्स्ट है, और फिर 2 का 10 है वो चाइल्ड है। चाइल्ड इस तरह से नेक्स्ट नेक्स्ट ओके। order and connected via child pointer. Return this linked list such that all nodes appear in a single sorted layer connected via child pointer and return the head of the modified list. Okay, ये sorted है, बट ये sorted है ज़रूरी नहीं है। ओके, वन वन। बेसिकली अपन को फ्लैट करनी है लिंक लिस्ट। हेड है। लेट्स से समहाउ अपन ने ये मिनिमम ढूंढ लिया, ठीक है। ओके, या तो एक काम कर सकते हैं कि सारे हेड तो है अपने पास, सारे हेड पे अभी एक एक पॉइंटर रखो, जो मिनिमम है उसको ले लो 3, और उसको आगे बढ़ा दो। ओके, लेट्स एक प्रीवियस पॉइंटर है, प्रीवियस इज इक्वल टू नल, करंट इज इक्वल टू हेड है, ठीक है। अब प्रीवियस, अब इस हेड को मैं इधर ले गया, इधर ले गया, इधर ले गया, मिनिमम इधर ले गया। ये मिनिमम आया, तो प्रीवियस मिनिमम डॉट नेक्स्ट इज इक्वल टू प्रीवियस, उसके बाद प्रीवियस इज इक्वल टू करंट, करंट मिनिमम, करंट मिनिमम, ठीक है। अब इससे पहले करंट मिनिमम का चाइल्ड अगर अपन, ओके, चाइल्ड अभी भी है अपने पास, ये जो नेक्स्ट वाली लिंक थी वो टूट गई, तो मिनिमम, करंट मिनिमम का जो नेक्स्ट है उसको पॉइंट करना पड़ेगा अपने को, ये इसके चाइल्ड, ये लिंक हटा के ये कर देते हैं, और ठीक है, ये हुआ। अब इसके बाद वापस से अभी इसे करंट मिनिमम देख लो, वही फॉर लूप लगा हुआ बेसिकली, है ना। और लेट से 4 ही आया, तो वो प्रीवियस ये है, तो प्रीवियस जो
channel. I hope you are doing extremely well. So today we'll be solving the problem flattening of a linked list from VSD sheet. But before starting off with the problem, if you haven't subscribed to our channel, please make sure you do subscribe to our channel. So the problem states that given a linked list of size n, where every node represents a linked list, yes, very important. Every node is representing a linked list in itself, and it contains two pointers of its type. One is the next pointer, which points to the next node, while the other is the bottom pointer, which points to the linked list, which is at the bottom of it. Now your task is to return the flattened linked list. Now this flattened linked list will be printed using bottom pointer instead of next pointer. Now let me explain this to you with the help of an example. So you can see this example over here. So 5 is the head of the linked list. So you can see that the 5's bottom pointer is connected to 7, 7's bottom pointer is connected to 8, 8's bottom pointer is connected to 30. So I can say this is an overall linked list which is connected to 5's bottom. Similarly, this is an overall linked list which is connected to 10's bottom. Similarly, this is an overall linked list which is connected to 19's bottom. And this is an overall linked list which is connected to 28's bottom. Now everyone is connected by the next pointer. This one is the next pointer. Now your task is to flatten this linked list. Yes, your task is to flatten this linked list. Now, in order to flatten this linked list, what we need to do is basically you have to convert this linked list into one linked list with bottom pointers, and it should be a sorted one. So you can see values over here. So all of these are sorted. You can see 5, 7, 8, 10, 19. So all of these are sorted values, and they're connected by bottom pointers. And the next of the first
कुछ ग्राफ जैसा नहीं हो गया है जो कि ट्रैवर्सल करते जाओ। हाँ
first node will always be pointing to null. So this is what you need to return as a flattening of a linked list. This is your task of CP. I'll have to introduce you to learn computer programming with OChef. Like if you feel that or the other is 12 months, along with this, you have additional like taking a linked list in this given linked list instead of n linked list. Like over here you have 4 linked lists. But just imagine if you had 2 linked lists, then how could you have solved the problem? So for an example, let's take only 2 linked lists to start off with. So let's take the 2 linked lists as linked list 1 as this and linked list 2 as this. Now if you want to flatten these 2 linked lists, will it not be similar to merging the 2 linked lists into one? Yes, it is kind of similar to merging 2 sorted linked lists into one sorted linked list. So we're going to use the technique that we use in the merge step in the merge shot. Now the first step what we do is we create a dummy node and we assign it to temporary and rest. Yes, 2 nodes will be assigned to the dummy node just because we want to keep a track of it. That is why I'm assigning 2 nodes. And right after this, what we do is we keep 2 pointers, one at 19 while the other one at 28. Now if you remember the merge step in the merge shot, what we did is we compared both of them. Yes, we compared 19 and 28. Now among this, which one is the smaller one? 19 is the smaller one. So what we do is we point temp's bottom to the node which is containing 19. Now remember, we're not creating any new node. We're just pointing it to the same node which is over here. So you pointed it to 19. Now right after this, what we do is we just move temp. Do not move the rest because rest will help you to get the head back once you have completed forming the entire sorted flattened linked list. So temp is over here. Now since 19 has been taken, move the pointer to the next. So you have 22. Now it's time to compare 22 and 28. Now which one is smaller? You can say 22 is smaller. So again the bottom of 19 will point to the node which is containing 22. Right after that, you will move temp to 22. And since 22 has been taken, you move the pointer to 50. After this, when you compare 50 and 28, 28 is the smaller one. So the bottom will now point to 28. And after that, you'll move temporarily to 28. So since 28 has been taken, the pointer will move to 35. So again, comparing 50 and 35, the smaller value that you get is 35. So the bottom of temporary is going to point to 35. So I can say after this, I'll move temporary to 35. Since 35 has been taken, let's move the pointer to 40. Now among 50 and 40, which one is the smaller one? I can say 40 is the smaller one. So let's take 40 and point the bottom of the temporary to 40. And after that, let's move the temporary node. Since 40 has been taken, we move the pointer to 45. Right after this, if I ask you 50 is smaller or 45, the answer is 45. So we point the bottom of temporary to 45. And after that, we're going to move temporary to 45. Now after this pointer will get exhausted. So that means the linked list 2 is empty. There are no further nodes remaining in linked list 2. So if you remember the merge step in merge shot, what we did is we copy pasted whatever is remaining over here. So only 50 is remaining. So we will copy paste 50. And temporary will now point to 50. Now you remember 50 will be pointing to null and 45 will be pointing to null. So 50 is also going to point to null. So once the 2 linked lists have been flattened into one, you can say that the bottom pointer of the rest, yes, bottom pointer of the rest will be pointing to the head of that flattened linked list. Yes. So you can simply point 19's next to null because that is what was required. So how can we use this to solve our original problem? Let's see. So we actually know how to flatten 2 linked lists into one. So why can't we take the last 2 linked lists and flatten them into one? So let's flatten the last 2 linked lists into one and let's see what we get. So once you flatten the last 2 linked lists into one, you will have a single linked list instead of the last 2. Now again, can I say, let's flatten these 2 linked lists. What if I flatten these 2 linked lists? So again, I'll get one more linked list. So let's do that. So now I flatten the other 2 linked lists into one, and what I get is a single linked list. And at the end, I can see I have 2 linked lists. Now what if I flatten these 2 linked lists into one? The result that I get is going to be the answer that I require. So I can say that the solution to this problem is super simple. What I can do is, I can start from the last 2 linked lists, merge them. Once they are merged into one, I can take it, and then I can merge it with the third last linked list. Once again they are merged into one, I can merge it with the fourth last linked list. And it can continue till we do not reach the first linked list. And once we have reached the first linked list, I can merge the first linked list and the resultant linked list. And ultimately, I'll get the final linked list, which will be my answer. So if I've understood the entire thought process and the logic behind solving this problem, the first thing while coding that will come to your brain is to use recursion. Yes. So what we can do is, we can use recursion. So initially, let's start with flatten, and we call L1. And since L1 is not the last node, what we do is, we again call flatten, and this time it will go to the next. So the next is L2. So we move to the next. And right after this, what we do is, we move to the next because L2 is also not the last one. So we move to L3. Now L3 is again not the last one. So we move to L4. So we're going to call on recursions. Now, the moment we reach the last node, that's going to be our base case of the recursion. So once you have reached the last node, that's going to be your base case. That is where you stop. And what you're going to do is, we're going to return the L4 node. So over here, you have the L4 node. So what you do is, before going back to this call, let's call a merge function, which will be merge L3 and L4. Now imagine merge of L3 and L4 gives you something as L5. So we get a single linked list in place of 2 linked lists, L3 and L4, that is L5. And that is what we're going to return from here. That is L5. So we are going to return L5. So over here, again, we're going to call the merge function, but the merge will happen between L2 and L5. So apparently L3 and L4 would have got a single one, that's L5. So now that L5 will attach with L2. give something new that is L6. Yes, so you're going to get L6, and that is what we're going to return from your L6. So L6 is what we are returning to the function call of L1. So over here, again, we're going to call a merge function, which is going to merge L1 and L6. So when we merge L1 and L6, we get a single linked list, which is this one. So when we merge L1 and L6, we get a single linked list, that is the flattened linked list, which is going to be our answer. So let's talk about the time complexity. Since I'm traversing through all the nodes, yes, through all the nodes, so I can say the summation of nodes, the summation of the total number of nodes will be my time complexity. And if I talk about the space complexity is big O of 1, because I'm using the same pointers. Yes, I'm using the same pointers and the same nodes to flatten them into a single linked list. So the space complexity is going to be big O of 1. Now it's time to discuss the C++ as well as the Java solution to this problem. So it's time to discuss the Java code to the approach that we discussed. So let's first discuss the merge step. So imagine you're given two linked lists, that is the linked list with having a head as A and the second linked list which is having a head as B. So your task is to merge them into one. So let's understand how we do that first. So as we did in our approach, we take two variables, that is the temporary and rest, and point it to a dummy node which is assigned to a value 0. Right after that, what we do is we keep two pointers. Right, one is the A pointer while the other one is the B pointer, initially pointing to the head of